Hi everyone, we're going to continue on with Chapter 4, this time with Section 5, and the title of this section is Graphing Lines Using the Slope, Y-Intercept Format of a Line or a Linear Function or Equation. As always, my YouTube channel is Ms. Jackson Math Teacher. The objectives of this section, first and foremost, is to learn how to rewrite a linear function in the slope y-intercept format. We actually already worked on this a little bit in Chapter 3, but I think it'll be clearer now why we did that as we start to graph. The second thing we're going to do is identify the slope from that equation and identify the y-intercept from that equation, and finally use both of those pieces of information to graph the linear function using the slope and y-intercept. Okay, there is not much new vocabulary here, but let's review some of the past vocabulary. Slope. As you recall, slope is represented by the letter M for mountain, and it is not a variable. Even though M is a letter, it's not a variable in the sense that it is varying or changing. In fact, slope is a constant. If you don't have a constant, if you don't have a fixed number for a slope, it is not a line. And remember, we've been doing this a lot, slope is rise over the run, or rise divided by the run, or really, it's a ratio. If we remember in our last section, rise over run is a ratio, and it is basically comparing the change in the y coordinates or y dimension. I'm going to represent that as delta. This letter here is a Greek letter called delta, and that's for change. It stands for change of delta y and delta x. So the rise is going up and down, and the run is going left and right, and that ratio is really trying to describe how steep or how flat the line is. And we've also already talked about y-intercept. Y-intercept is the location that a linear function intersects. If you don't like that word, you can say crosses the y-axis. And if you recall, we also have an x-intercept where that would be a point location where the function crosses or intersects the x-axis. Okay, so slope y-intercept form of a linear equation is written as y equals mx plus b. This m, as I said, stands for slope, and it's a constant. So m is just a pure number right in front of that x. And this b here stands for the y-intercept. And this sort of makes sense if you look at it. The y-intercept, and we've spent a lot of time on this, the y-intercept occurs when the line crosses somewhere on that y-axis. And at that point, right there where it crosses the axis, we know, of course my alignment on my iPad is not great, but we know that everywhere along this y-axis, x is not positive, x is not negative, x is 0. So here we know no matter what, that y-intercept has x equal to 0. Well, if we substitute x equal to 0 here, then of course that term would just cross out. And so y equals this placeholder here. It is represented by the letter b, and again, it is not a variable, it's an unchanging number. So if this just crosses out, then y equals, and this will be the y-intercept when x equals 0. Let's review the word coefficient. That is actually my dog Daisy barking right now. Somebody must be walking down the street upsetting her. Coefficient is a big word, and it is the number right in front of a variable. And so if you look above, I bring up the vocabulary term coefficient because the operation between the coefficient and the variable, as we know right here, in between m and x, that operation is multiplication when they're hugging each other. And in this case, in the standard form of a line, in the slope y-intercept form of the linear function, m, or the slope, is the coefficient in front of the x term. So the slope is the coefficient. Okay, one last vocab term here, and that is parallel lines. Parallel lines are lines that will never intersect. The reason why they will never intersect is because they are equidistant. That means equal distant, but we kind of mash up the two words together, equidistant from each other. Just read that as equal distance from each other. Parallel lines on the coordinate plane have the identical, the same slope. Okay, so if you look at parallel lines here, put on the coordinate plane x and y. If I draw, and I'm sketching now, so they're not going to be perfectly parallel, but if I attempt to draw parallel lines, they look like this. Next year in geometry class, you'll mark parallel lines with sort of these filled-in arrows. And basically, they are equidistant everywhere along the two lines. They are equidistant, equal distance. They'll never intersect, and they have exactly the same slope. Okay, so let's look at a couple of examples. Standard slope y-intercept form of the line. Y equals mx plus b. And we talked about that coefficient m is the slope. So that coefficient here, right in front of the x term, is the slope. Slope is really meant to be a ratio. So here we have m equals 2. You really should rewrite that as 2 over 1. 2 over 1, 2 divided by 1 is 2. So they are equivalent numbers. But really, slope is meant to be a ratio. So let's rewrite that 2 over 1. And then here, the b is just a placeholder for the y-intercept. And we know that that's where the linear function intersects the y-axis. So we have the y-intercept, b, equal to 1. So how would we take that information and graph? Well, I recommend you always start with the y-intercept, because that's just a single point on the y-axis. So we know here, if the y-intercept equals 1 here, then we could rewrite that point as 0, 1. In other words, the x is 0 and y is 1. So let's go to that point. 0, 1, that's right here. I'm going to try to put a point there, although I recognize that the graph is very small. Now let's use that kind of as our anchor. From that point, we're going to start to use our slope. What is the slope? The slope is rise over run. So I'm going to just remind myself of that. And in this case, our slope is positive. It's a positive 2. That means if we go left to right, we're going and walking uphill. Remember our little guy in our other notes? We're walking uphill. This is a positive slope. So, what do we got to do? We're going to go up 2 and over 1 to the right. So here we go. I'm going to take my y-intercept and I'm going to go up 2. 1, 2. That brings me to 3. And I'm going to go over 1. So let me put a little point there. You know what? Let's keep going with that. Let's start from this point. Go up 2 and over 1. Rise 2 and run 1. I can even go in the reverse direction here, starting back at our y-intercept, and I can go down 2 and over 1 if I want to go in the opposite direction. Down 2 over 1. And what do you have? We have a nice straight linear function. And we have a slope rise over run of 2 over 1. positive 2 over 1. And we have a y-intercept of 1. All right, let's take a look at example 2. Again, the slope y-intercept form of a line is y equals mx plus b. So here we have y all by itself, which is what we want. We want it to look just like this form, so y has to be completely by itself on one side of the equal sign, and it looks like the slope here is negative 1 over 3, negative 1/3. So that's our slope, it's negative. And we have a y-intercept of positive 4. We know our y-intercept is always going to be at x equals 0 and whatever our y value is. Okay, let's remember though that a negative slope means if reading left to right, we're going downhill. So let's always keep in mind what kind of line we're looking for ultimately. Again, start at the y-intercept. Use it as your anchor. So 0, positive 4 would be right there. Now we want to go down 1, because it's negative, and over 3. So our rise is actually going down because of that negative sign, and over 3. So starting at our anchor here, we're going to go down 1 and over 3. Down 1 and over 3. Down 1 and over 3. And we can go in reverse as well. So we're going to go over 3 and up 1. Over 3 and up 1. And you can see we've got a nice linear function. My line is not so straight because I'm sketching. Okay, here we have a slope that's negative 1/3. And we have a y-intercept, which we represent with the letter B, as positive 4. Example 3. Again, we want y all by itself. Y has to be completely by itself. Equals mx plus b. What do we have? The coefficient in front of our example, m, equals 3 over 2 or 3/2. Remember, rise over run. This is the rise, and it's positive. 2 is the run, also positive. Now we have a negative y-intercept here. We have to grab that sign in front of there. Subtraction, but remember subtraction is the addition of a negative number, so you can almost use that as the same here. So our y-intercept equals negative 2. Again, we can always write that as a point location. X is always 0 on the y-axis, and y here equals negative 2. So start with this point, and we're going to go to y equals negative 2, and x is 0, and that would be right there, and that's going to be our anchor. Now, we have a positive slope. A positive slope is walking uphill, so remember that our line should be walking uphill, and we're going to go rise 3 from this y-intercept point. 1, 2, 3. Let me show that with a pointer. So 1, 2, 3, and then over 2. 1, 2. So we've got a point right here. Do it again from this point. Up 3. 1, 2, 3, and over 2. Do it again. 1, 2, 3, and over 2. And we can go in reverse. Go down 3. 1, 2, 3, and over 2. Etc. And I'm going to sketch my nice straight linear function. I have a slope that equals positive 3/2, and I have a y-intercept that equals negative 2. I think you've got the hang of things here. Now, here in our example for y is not by itself. Y has a coefficient. Y has a coefficient 2 in front of it. We can't have that. We have to have y completely isolated and by itself. So we need to get rid of that 2, and of course 2 is multiplying y. How do we undo that? The inverse operation of multiplication is division. So I'm going to go ahead and divide this 2 out. When I do that, over on the other side of the equal sign, I have to divide out the entire enchilada here. So everything's got to be divided by 2. So I've got 2 divided by 2 that reduces to 1. And we've got y by itself, which is what we want. We have negative 6x divided by positive 2 is negative 3x. And positive 8 divided by positive 2 is 4. Now, we have what we're looking for. We have our y here. I'm sorry, I misspoke. Our slope, m, is negative 3. And remember, I really like to represent that slope as a ratio. So negative 3 is an integer. That's the same thing as negative 3 divided by 1. And then our y-intercept, b equals 4. We can rewrite that as a point location, 0, 4. All right, just a reminder, negative slope, we're walking downhill, left to right. Okay, so go to our y-intercept. Again, it's 0, 4. We're up here. Start that with your anchor. Now, we are going down 3. Our rise is going down, and our run is 1. So we're going to go down 3 from that y-intercept. 1, 2, 3, and our run is 1. So we're going to go over to the right 1. So we're going to end up here. Do it again from this point. Down 3. 1, 2, 3, and over 1. I hope you're seeing this. Down 3 and over 1. Do it again. Down 3 and over 1. And you can do it in reverse. Up 3 and over 1. And you can draw with your ruler a nice straight line, which is going to look better than mine since I'm just sketching. So this slope here is negative 3, going down 3 for every 1 unit to the right, and the y-intercept is 4. Example 5. Well, we certainly don't have y by itself. Y is being multiplied by 4, and we're also subtracting 2x here. We need to get everything away from y. So remember, PEMDAS, we are isolating y. Okay, we're trying to get this y all by itself. And y is being multiplied by 4. But we're also subtracting here the 2x. So we're at this level. We want to undo these operations from the bottom up. So the first thing we're going to do is add 2x to both sides. And here we go. We've got 4y coming down. Opposites, negative 2x plus 2x reduces to 0. Now, 2x and negative 12, they're not like terms. They cannot really combine. And I do want to put this x term first. That's more of our convention here. We're putting the x term first, and then the pure constants over here to the right. So 2x, positive 2x is just 2x. And then we're subtracting 12. They can't combine. They're not like terms. All right, so now what do we have? We've taken care of this level, so now we're ready to undo this multiplication. We undo multiplication with division. When I go to divide by 4, the whole enchilada's got to see that division. So y, of course, 4 divided by 4 reduces to 1. We've got 2/4 x minus, and 12 divided by 4 is 3. So I might as well simplify that. Now, some of you are seeing this 2/4 here. Could we make that 1/2? Sure we can. We could certainly make that 1/2 if you want, but you don't have to. We do know that the coefficient here in front of the x term is our slope. So right now our slope is 2/4, or you can reduce that out and say it's 1/2 if you want to. No biggie if you don't want to. And then the y-intercept here equals negative 3. Start with the y-intercept, and that location there is 0, negative 3. Start with that y-intercept. So we've got 0 and negative 3. So there's our y-intercept right there on the y-axis. And let's look at our slope. Our slope is positive, therefore we're walking uphill. So let's go up 2. I'm not even going to bother simplifying this. I'm just going to use the 2/4. So I'm going to go up 2 units here, up 1, up 2, and over 4. 1, 2, 3, 4. So I'm going to end up right there. And I'm going to do it again. Up 2 and over 4. 1, 2, 3, 4. And let's go in, whoops, I have a little stream mark there. Okay, let's go in reverse. I'm going to go over 4. 1, 2, 3, 4, and down to 1, 2, right there. Now, for those of you who wanted to reduce this to 1/2, you can do that. I'm going to do that in a different color here. Say I started from my y-intercept here and I decided to go up 1 over 2. That's fine. You can do that. That would be right there. Up 1 over 2, I'd end up right there. Up 1 over 2, right there. I'm just ending up with a more finer detail here, more points. And I can just draw my straight line with my ruler in between all the points. I've got a slope of 2/4, that's equivalent to 1/2, but whichever you prefer is fine. And then the y-intercept, which we represent with b, is -3. Final example. Here we have 4 minus x equals 2y. I don't want this y, well, let's just go to the y. Always go to the variable you're trying to solve for and isolate. That's what we're trying to do when we solve for. We're trying to isolate y. We want y all by itself. So go to y. Y is being multiplied by 2. How do we undo multiplication? We undo multiplication with division. So I want to get that y all by itself. When I do that division on one side of the equal sign, everything's got to see that division. So here we have 4 divided by 2, that's 2, minus x divided by 2, you could leave it as x divided by 2, that's fine, equals, and then 2 divided by 2 reduces out to 1, so y is all by itself. Now, if you don't like the order of these things, we can rearrange. You can put the y over on this side if you want to in this format. So we can just say y equals, I've got a negative x over 2, because of course this sign here goes with this term, and the sign with the 2 is in front of it. If you don't see a negative, it's automatically a positive. Okay. And if this confuses you, this negative x divided by 2, just rewrite it, it's fine. Y equals, this is the same thing as negative 1/2 times x plus 2. So we have a slope, that's the coefficient in front of the x term, of negative 1/2, and we have a y-intercept, whoops, I want to call that b, a y-intercept b equal to positive 2, which of course is located at 0, 2. So, go to that y-intercept always first, 0, positive 2, and we have, we're going down 1 because it's negative. Let's remind ourselves, this is a negative slope, going down, going downhill. We're going down 1 and over 2. Going down 1 over 2. Going down 1 over 2. And we can go in reverse. Go over 2 and up 1. Over 2 and up 1. And you'll see a nice linear function form here. So here we're going downhill. We have a slope of negative 1/2 and a y-intercept of positive 2. Okay, so hopefully we've learned how to rearrange linear two-variable functions here into the slope y-intercept form of a line, and then identify what is the slope from that equation, what is the y-intercept, and how to use that information to actually graph our linear function. Okay, if you like this, subscribe to my channel, and I'm saying that because one of my students, Gabriel, keeps telling me to say that. All right, have a good night. Thanks for listening.